All right, guys. Taking a look at this video. This will be video number 2. Certain parts may be repeated because I have different videos going up. But I'm going to call this a power review. And this will be video number 2. So with this power review, I'm going to go back over where I last stopped on the last video, talking about complex numbers. And so here's a typical problem with complex numbers. This is a subtraction problem. And for some reason, a lot of students get confused on this problem. This is a subtraction problem versus a multiplication problem. So as you can see, it's two different problems. So people want to work the subtraction problem like it was a multiplication problem. So this first one, the one on the left, is really simple. It's 3 subtract 12, which is negative 9. And the second part would be 7, this 7 right here, 7i subtract 10i, which is a subtract 3i. That is the answer to the one on the left. Now, the one on the right is multiplication, and you can either use the box or FOIL. Most students like FOIL, so I'm going to show you by FOILing there. And I'd get 36. 3 times 10 would be 30i. 7i times 12 is 84i. And 7 times 10 is 70. But the difference is it's I squared. So be careful on the I squared whenever you're foiling these complex binomials. So going to the next line, we're going to have 36 plus 114i plus 70i squared. If you pick that answer on test day, you're going to get it wrong because this I squared has to be simplified. So we'll get 36 plus 114i plus 70 times negative 1. I squared is negative 1. You have to do that. Continuing on with the problem, you get 36 plus 114i subtract 70 at this point. Right there, subtract 70. Final answer is going to be negative 34 plus 114i. Completely different process because it's a completely different problem. Any questions on that? All right, continuing on with complex numbers, I want to talk about this type problem here. Here's another one that you will encounter, and this is good intel I'm giving you guys because I'm kind of giving you a little bit closer look at what could pop up on the test. And here's a typical problem. Here they'll say simplify the complex number or divide or something like that. You cannot work this problem without using a conjugate. So this is what a conjugate is in case you've forgotten. In this denominator, we keep the 4. We change it to plus 3i. And you have to multiply the top and the bottom by that plus 3i. That's finding the conjugate. Then essentially from this step, you're going to have 2 binomials that you got to multiply together. So up top, 3 times 4 is 12. 3 times 3 is 9i. Right there. So I'm just foiling. 3 times 4, 3 times 3. Then I'm going to FOIL again. I get subtract 8i. And then subtract 6i squared. You got to be careful with that those last couple right there. Then you do the same FOIL method on the bottom. You get 16 plus 12i subtract 12i subtract 9i squared. The problem is not so much with the FOIL as with handling these I squares. So let's go through and simplify. You get 12 plus I. And then the tricky part is right here on the I squared term. That's a negative 6 times a negative 1. So you got to be careful with that. Down here, you get 16. The 12s cancel out. You subtract 9 times a negative 1. And it starts to look a little confusing right here, but don't worry about that. 12 plus I, this is going to become plus 6. And down here you get 16 plus 9. And you go ahead and finish it out. 18 plus I over 25. Or there's another answer. One of the books called it 18 over 25 plus, what do they call it? 1/25 I. So these are the same answers here and here. It's the same answer. All right. Yeah. Push that up so you guys can see it. There you go. These two on that last step are the same answer. All right. Any questions? This is an 18, by the way. Those are complex numbers. All right. Continuing on with this power review. All the problems on the test aren't complex numbers. There's some basic ones that you should want to, slam dunk, so to speak. Jamil, you like that? Slam dunk? Slam dunk a problem, right? I guess he didn't hear me. 4x plus 9 equal to 2x plus 7. You don't want to get so caught up in hard problems and forget how to do the basic ones, guys. There's a problem like this, a basic double-sided equation. All right, 2x plus 9 equal to 7, subtract 9, and then you get 2x is equal to negative 2. So that means x is equal to a negative 1. Very basic problem like that you should be very comfortable doing. What else could be on the test? They could give this problem to you as an inequality, and you'd have to do basically the same thing. All the middle work would be the same, but down here you'd end up, all this in here is the same as the left side. You end up with x less than negative 1, and if you had to graph it, that'd be an open circle going to the left. So basic equations and inequalities, you definitely want to know don't want to forget how to do those. A little bit more, some other things that you got to know how to do. And some of the stuff in the videos may repeat itself a little bit, but it's okay. Let's go back to this thing called zeros. Okay, zeros. When we're talking about zeros, we're talking about the numbers that make the equation 0. So here's a typical problem that could pop up on the test, zeros. This one right here is pretty easy. So this one factors down to x plus 3, x plus 1 equal to 0. Now remember, when you're dealing with these zero problems, your factors are not your solutions. So you have x is equal to negative 3 and negative 1. Those are x values or your solutions. Remember, the factors and the zeros have different signs. This problem will be pitched to you as a multiple choice problem. So even if you forgot how to factor, suppose you had something like this, negative 3, negative 1, let's say negative 3, 2, 4, 0, and positive 3, positive 1. Suppose it was a multiple choice, something like that. Even if you forgot how to factor, you would just simply plug these x values into the equation, and whichever values gave you 0 would be your answer. And both of these have to be true. So, for instance, we already know the answer is going to be C. Let's say I went through these others now, and I arrived at C. I should get 0 for both of these, okay? Should get 0. So this is how you check the problem to make sure it's right. See right here, 9 plus a negative 12, or you could say subtract 12, plus 3 is equal to 0. 12 subtract 12 is 0. 0 is equal to 0. So I know -3 is good. But if you look here, you have two answers selections with -3. So what you would have to do is test both. So I'll then test the -1 because I already know that's the answer. But doing it this way is a little bit longer, but you'll get the right answer if you're patient. You got 2 hours, so there's no rush. You only have 45 problems, and some of them aren't hard. So it should be more than enough time. So you end up again with 0 equals 0. So both of those are good answers. Choice C. That's a 0. What else could pop up on the test? Some very basic stuff that you don't want to miss is some problems. Like again, you want to make sure you slam dunk them, so to speak. You're just not going to miss them. For instance, if you have a problem, let's make up something here. Y is equal to x. Y is equal to x squared. Y is equal to x cubed. Then x to the 4th. Y is equal to x to the 5th. What they expect you to do is know the little fancy name given to these. This is a linear term. It's linear because there's a 1 here. They're not going to write the 1, but it's there. X squared is quadratic. You got to know that. X to the 3rd is called a cubic. X to the 4th would be what? A quartic. And anything x to the 5th would be quintic. Okay, now that's just the fancy name given for the degree. There's also a name given for the number of terms. If it's one term, it's called a monomial. One term is called a monomial. Monomial, it's spelled right, monomial. It's N, by the way. And 2 terms would be a binomial. 3 terms, trinomial. Anything beyond that, we just call it a polynomial of 4 terms or 5 terms. There might be a special name given for that as well, but we don't generally deal with it. So you could pair any of these up with the other. For instance, you could have a cubic binomial or a cubic trinomial, a cubic monomial, okay? So on and so on. So this is the number of terms, okay? And this is the degree, okay? So two different things going on there, terms and then the degree. You got to know how to do both of those. All right, so we got that. Here's my next question to you. I think Jaden's going to help me out on this one. All right, Jaden, here's your question. If you have x to the 5th plus 4x, subtract 7, let's put it equal to 0. How many roots does this problem have? How many roots does it have? 1. All right, I'll give you a 50-50, 4 or 5, 3 or 5. Well, it actually has 5 roots. Okay, so whatever. Here's if they say something like this: how many roots? How many roots does the polynomial have? Polynomial have, and then you would say 5. In this case, it's 5. Your degree and your number of roots always match up. That's from the fundamental theorem of calculus. So think about it. It kind of makes sense. If you have something x squared, y equal to x squared, you know there's going to be 2 answers there. Or if it's y equal to x cubed, you got 3 roots or 3 zeros. Now that's different. That's a different question than this. So pay close attention. That's your number of roots. This thing has 5 roots. If the question is name all the rational roots, that's a different question. Okay, they sound almost alike, but it's different. This is asking how many roots. This is say name all the rational roots, or they could say use the rational